Yeah, simple stresses. So now we are going to tackle stresses or pressure or stresses that can be found in thin-walled pressure tanks or thin-walled pressure vessel. Okay? So, wait ha. You can say that a pressure tank is thin-walled if it has a wall thickness less than about 1/10 of the radius of the container. Okay, so because some questions are very tricky, class, especially if it is in your board exam. So you will be asked if this pressure vessel is like that, but in the end, dili siya thin-walled, so all your computations are wrong. Okay, mainly dili siya thin-walled, so you don't have to solve or sa banayin ana nga type of test. So the wall thickness of the tank is less than 1/10 of the radius of the container. So radius had diameter. So always bear that in mind. So when solving thin-walled pressure vessels, let's always check first if we are solving a thin-walled pressure vessel itself. Okay, basig dili na siya thin-walled. So check if the wall thickness of the tank is less than 1/10 of the radius of the container if you are given the radius. Okay, so there are two types of stress that can be found or that is present in a thin-walled pressure vessel. So muna atong this is very short lang. It is the tangential and the longitudinal, sorry. So, ang kalahian na nila ni class is where the stress is located. Okay? So when you say stress, diba, inner pressure or inner effect of the outside pressure caused. So for tangential, this is also called, or another term for tangential stress is circumferential stress. So let's consider the tank shown in the next slide. So this is the tank. So it is just a figure na showing the internal pressure and forces caused. So we have a pressure to the sides of the tank. So for example, kung ano na siya, fluid, either gas or liquid. So it causes pressure to our to the body of the tank. So along with that, we have equal or opposite stress or force nga ma-cause ana niya. So I am going to show you how to derive the formula for the said type of stress. So for tangential, we have a pressure nga nag-cause sa iyahang sides. So using a free body diagram, as you can see, we have here the half of the tank. I'm showing you the half of the tank na atay force F caused by the liquid. So that force F is equal to P times A, or pressure times the area. So the area of the yes. So the area of that pressure cost is the diameter, so sides man siya, diameter, multiplied by the length of the tank. So rectangular ang iyang area. Then, for the opposing force, we have the stress now, the stress of the wall, and the area of the wall. So, muna siya ang opposite stress nga na-cause niya. So, pressure, ang pikas area. So, the area is the thickness of the wall of our tank and the length. So, muna siya for tangential. It is tangent. So, the pressure causing is tangent to the wall of the tank. So, to derive, simply, sum of forces horizontal, kay mo lang may naa. So, we have F is equal to 2T. Tuhaman kabuk atong present nga reaction since do atong sides at tank if ato siyang iha. So, 2T. So, substitute the values, PDL to sigma T or sigma of the wall, TL, gayon. Simplify, we simply get PD over 2T. That's for stress tangential. Okay? Okay lang? Ba, dali na kayo. Okay, next. So, next is the longitudinal stress. For the longitudinal stress, lahi na po siya. The total force acting at the rear of the tank must equal to the total longitudinal stress on the wall. So, meaning, kanina siyang sa rear na po niya, nag-cause of stress. So, since T is so small compared to D, the area of the wall is close to pi dt. So, for this, wala ko yung representation. For this, ato na siyang i-assume nga T is so small. So, ato na siyang i-assume nga ato ang wall, ato ang area is pi dt. So, that's for the force sa ato ang rear. So, diba, pi dt, area of the wall. So, ito na siyang sa ato ang babaw class katong gapalingin. Okay? For longitudinal. So, first, natay pressure na gikos, the F, which is P times A. Same lang gihapon. P times A, P. So, pi over 4D squared. Kato naman ang circular nga part. Diba? Katong ganyan itong gi-analyze is the sides. Kani siya, kato naman sa circular nga part. So, we use for F, nga, muna siya, ang F is the one that causes the stress, muna siya external na to. Kumbaga, so P times A, pressure, cost, and times the area. So, pi over 4D squared simply. For the longitudinal stress cost, we have a force P. So, that is causing stress L times pi dt. Since the diameter is, the thickness is so small compared to diameter, kay 1/10 traban siya, di ba? So, wala siyang gihimo na to siyang pi dt. So, that's how they explain it in the book. So, by summing up forces horizontal equal to 0, we equate PT and F. So, substitute, simplify, we get PD over 40. Hagitabo na niya. Dala. PD over 40. So, basically, stress tangential is just twice of that of the stress longitudinal. Okay? Very easy lang ni siya, class. If tagaan ta mo exam ani, direct substitution lang siya mostly. Dali naman kayo, no? Kaya magkopyahan na naman mo. Wala ning katawa, so tinuod. Oh yes, Ma'am Judy. Joke. Joke. Gabaway pa dahil.
Wala siya mga sa Google Map.
Gabay na, ning paano sila, ning chat na. Manakag-answer ba yun? Itabay di, baby, kapuyag sa diri ba yun? Dahil na. Para-paraanin niyo. Okay, so another one is the spherical shell. So, what if it is in a spherical form? So, if a spherical tank of a diameter d and, as shown, thickness T contains gas under a pressure P, the stress of the wall can be expressed as PD over 40 lang. So, if it is mentioned in the problem, a spherical tank, diretso, PD over 40. Pag mo na gani, a circumferential, okay, unsa gani, PD over 2T. Wala lang, inana naman po na. Okay, so let's have an example. So, a cylindrical steel pressure, so cylindrical na siya, dili na siya spherical. Okay, so cylindrical na ha. So it's either of the two, katong longitudinal or the tangential. So it has a 400 mm in diameter with a wall thickness of 20 mm. So compare daw, 1/10 of the radius. Okay, Ras? Thin walled siya. So is subjected to an internal pressure of 4.5 meganewtons per m squared. So first, calculate the tangential and the longitudinal stresses in the steel. Okay, so we have a steel here. And B, to what value may the internal pressure be increased if the stress in the steel is limited to 120 mn per m squared? Okay, that's it. And C, if the internal pressure were increased until the vessel burst, sketch the type. Dinataan na, kaya dito ka wala mo sketch. A and B lang itong ansiran. Okay, so first, you're asked. So if I were to solve this, I am going to list down first what are the given. So wala na yung list down. So what are given? We have here a 400 mm diameter, thickness nga 20 mm, and an internal pressure of 4.5 meganewtons per m squared. So let's use our formula. For tangential stress, we have F is equal to 2T, or PDL is equal to 2 sigma TL, or automatically, let's just use PD over 2T. Di na tamo agi ana. Since pag ingong tangential, automatic PD over 2T. So we have a pressure. We have 4.5 meganewtons per m squared. And we have a D, diameter of 400 mm, and 2 times T. So computing, we have 45 MPa. Diba? Easy. Dali na kayo. For the longitudinal. So, the same. Use PD over 40. So, substitute the values, we get 22.5 MPa. So, as you can see, tangential is just twice of that of the longitudinal. Very easy lang siya, di ba?
Easy na lang.
Easy na lang ta. Easy na na. Direct substitution lang. So, do you have any questions? Wala, Ara?
Tayo.
Ma'am.
None. Okay, wala na. So, for the next question, to what value may the internal pressure be increased if the stress in the steel is limited to? So, we are given here the limit sa atong stress. So, meaning, paano na to ang iyahang pressure? So, bali na po tayo ni class. So, we have the stress, we have the 120, then the P is the missing. So, we have 400, 2T. So, inyo na siyang i-compute ang duha, then compare which is critical. So, this shows that tangential stress is the critical. Kaya nga naman, ang nakuha na to is 12 MPa. So, if you're going to compute for the na may calculate, ilang values sa kuan. Sige niya itong ikuha. Pressure, no? So, tangential man siya. So, meaning, half lang ang pressure ani sa. So, 6 lang ang kuan ani. 6 lang ang sa tawag ni longitudinal PD. So we have gusto ko calculate. Ay, hala, nakamute ko.
Gali, ma'am. Gali, ma'am.
Nakamute ko. Sorry, gayaw-yaw ko. My God.
Edit pa kami. Sabi na, formula, ma'am.
Oh my God. Gayaw-yaw ko.
Sabi na mo, sila kaslain na mga kan.
Ay, char.
Hindi ka tapod.
Tingala ko. Di ba sila maningaw? Ganyan ako sige pangutana. As I was saying, before we decide to use the tangential stress and the critical, we are going to compare the two. But why? Why did we use the 12 MPa and not the 24 MPa between the two? So, ingon ko, maka-answer, patar na. Ben, why do you think did we use?
Kay gamay, ma'am.
Oh, nga nung gamay siya. Kano day gamay siya? Obvious na siya nga gamay siya. Kaya ano di I explain it to me. If you really understand. So why is it that tangential is critical? If we limit the stress, the stress to 120 meganewtons per m squared, why won't we use 24 MPa na as the maximum? And why did we use 12 MPa as the maximum pressure na for this specific tank? Wala?
Sirit, ma'am.
Hmm?
Wala, ma'am.
Wala di ay. Because it is lang. Yes? Maybe because parang it allows about the internal pressure. Wait, sabi ka. Sa to, pagsa. Okay, again? Hello? Medyo choppy ka, miss. So from what section are you? What course? Architecture, miss. IBS architecture. Okay, from the architecture, so let's hear his or her answers. Is it all?
Ano, mama, I'm not sure, ma'am, pero I think we use the formula for tangential since it stated that the value made what value pressure, and for tangential, I think that we talk about the pressure inside the tank, while if longitudinal, it just will pressure the
No, they're both inside the tank. Yes, thank you so much. Ay, almost there na.
okay.
But you just have to say, naisa ka point ka dapat iingon for us to say ano siya, we use tangential instead of actually something related to the maximum because we are limiting the stress here to 120 MPa. So what do you think?
Para di mo buto, ma'am.
Yes, para di mo buto. So why did we use 12 MPa? I want you to explain it in sa ato ang klase. Relating sa tangential and longitudinal stresses. Sige, huna-huna, Jud. Basi di nara mo idea di aklas ni naulaw ra mo ha. Ay mo kaulaw. Basi di magka-friends pa mo aning mga ii. Yes, mao iyang limit. Then why? Explain nga nang mao iyang limit. Ganong dili 24. Ganong 12.
Excuse me, ma'am. Maybe
Yes.
because ma'am kanang ang stress kay limited to 120 na, ma'am.
Oo,
Ano,
then?
guys?
Yes, gano. How do you justify that statement?
You're just repeating what she said.
Wala, sige. Wala na yung nakapasar. Exempted na sa next quiz ang maka-answer. Okay, sige, di na lang. Okay, so I'll explain.
Kay Kon, ma'am.
Pwede mo hirit. Sige, yun sa man.
400 divided by 40. Kanso? I-divide sa Ogpan. 10.
I-divide siya og 10. Ang sa? Okay, so I'll explain na lang class to make it clear. Okay, so we use here 12 MPa for our pressure because we are asked for the value nga extent lang nga increase na to ang atong pressure if the stress is limited to 120. So ato na siyang ibutang ang 120 na to is the constant or di siya dapat mo change. Hindi siya pwede mo change ang 120. So we are going to check for both if unsa siya. So for longitudinal, atong nakuha nga stress ay nga pressure is 12 MPa. So ato na siyang i-check sa duha. Ato siyang gamiton if ang atong pressure, for example, we have a tank. Then inside we have a 12 MPa nga pressure. So mo naman na siya atong pressure, so it affects both longitudinal and tangential. So first, let's check if sa tangential. Ato siyang i-check. Let's use 12 MPa. So 12 PD over 2T. So if it exceeds 120, therefore, di siya pwede. So 12 PD times 400 divided by 40. So we have 120. So okay. Diba? So let's check again for PD over 40. Let's check for the longitudinal area if ang itong pressure okay ra ba. So 12 times 400 divided by 40. So, 40 man. Joke. So 12 times 400 divided by 4 divided by 20, we get 60. So 60 lang ang ato ang makos ay murag tawagan na stress nga makos. So okay siya, pasado. How about for the 24 MPa? If we have a pressure of 24 MPa sa ato ang tank na, we are going to consider the longitudinal stress and the tangential. So first, let's check the tangential. We have 24 times 400. The same properties, magyapon ito. 24 times 400 divided by 40. We get 240 already. So meaning, nibuto na niya itong tank ani, kaya ang limit 120 lang man. So that's the explanation that I want. Okay? So, so but na-gets ninyo to. We are not allowed to use 24 here because we are limited to 120 meganewtons per m squared. So, di siya pwede. Mo lapas man siya if the pressure is 24 na. How much more sa kuan? Pwede siguro siya sa kuan, sa tangential. So we have 24 times 400 divided by 4 divided by 20. So we have 120. Okay lang siya for the tangential, but for the longitudinal, mo exceed naman siya sa atong 120 nga limit. Okay? Nagets ninyo?
Yes, ma'am.
Okay, very good. So that's the kuan explanation for that. So okay. So let's move on to the next example. I hope you don't have any question na. Okay, so let's move on. So the wall thickness of a 4 feet diameter spherical tank. So pag ingon nga spherical tank, so automatic PD over 40. Okay, 40. Wait, let's find out lang. So, it is 5/16 inches. So, we are to calculate the allowable internal pressure if the stress is limited to 8,000 PSI. Okay, so, allowable internal pressure na pod. So, unsa ra may allowed niya nga internal pressure? Same goes with kuan, kaniha. Unsa ning gasend og picture? Asking to be let in. Sayop tagay niyang na-joinan. Taning or naano ni siya, naka-join na ni si Ivan. Singalan niya Ivan Mir na join ka rin pa siya. Hello, Ivan. Okay, so we are going to so derive lang niya ang formula gihapon. So we have PD over 40, we have 8,000 nga allowable or limited stress here, then the P, and 4 times 12 for the diameter. We get times na siya 12 plus to convert to inches because PSI is pound square inch. So 1 foot is equal to 12 inches. So we multiplied it by 12 over 4T thickness. So automatic man good nga pag spherical, mo ni siya ang formula. Okay? So that's 208.33 PSI. So direct substitution lang siya mostly, but napod may gamay nga i-analyze like for the mga allowable or the maximum, diba? Tricky po siya, so wala lang. Okay, so do you have any further questions about the previous topic? I move on to strain. I will just briefly discuss strain tonight. Kaya na po kayo next class. Then, I want you to prepare for a quiz next meeting na. Okay?
Okay, ma'am.
Okay, mag-screenshots ako ha. Di man na ikabot mo 100. Yuhuhuhu.
Excuse me, ma'am. Nakamute na po ka, ma'am.
Nag-screenshot pa ko. Wait sa guys ha. Okay, so asa na kita? Strain na strain. Excuse me, class. Galain akong ilong. So, mana ba mo pa ko ang tanan? Vaccine? Or nabay anti-vaxxers nyo din? Kaya mo na lang sila itong pag-asa gid magka face-to-face.
Mana ma'am, di lang mamin na form.
Pagpilat na mo para mahumanta niya itong mga survey. Uy, kung kapoy, dyan na batang pangduklon.
Ay pa high school, kinag-face-to-face na sa face-to-face ma'am.
Mo, Jud. Mas ada ganing face-to-face ninyong mga ipangbungot naman ta mo.
Ano talaga yung ma'am? Okay, niya sa election ng elementary may walik klase.
No, nidis ka ka-vote. My gosh. Ay, kay gamitin lang school, guys. Ano lang mo? Okay, I strain. So, simple strain. So, this is also known as unit deformation. Strain is the ratio of the change in length caused by the applied force to the original length. So, meaning sa strain, mura na siya iyahang. Saba? Pagkainat, pag-compress, depending sa iyahang force na i-apply, it's either gi-pull ba siya or gi-push. So, for example, if the rubber band is being stretched to the extent nga ma-deform siya, so muna siya ginatawag na to og strain. Unit deformation. So, pag inat na to sa rubber band, pag buhi na to, ano siya nibalik sa iyang original nga unsa siya, or na inat na siya. So, that's what we call strain. So, it is is, sige, ito kung gingon. So it is measured or it is, so strain is the deformation over the length where kani siya nga symbol sa na siya is the deformation and L is the original length. The strain is dimensionless. Okay, so next, these are the terms that I want you to familiarize. So first is the proportional limit. Hooke's law, the meaning is the constant. So basa lang ninyo class. So basa-basa ko ano, useless ng gyapon kay. Kung ano man na siya, very self-explanatory. Kana. Okay? So I'll discuss this more next meeting na lang class. Okay ra? Including the problem, excuse me. Tulo ko sipon. Sorry guys, nagmasakit. Bakit bawal ba ha? Charot lang. Okay, sige na kay tamarag. Napa ni appointment ni uban diri sa kalibutan. Okay, so wala na may question about sa kung ano sa thin wall pressure. Remember ha, thin wall pressure vessels 1/10 of the thickness radius. I-check before mo mag-solve. Kaya ba sinailaran tamo. Okay. Sige class. Thank you for being with me tonight. God bless. Bye-bye. Bye-bye. Bye, ma'am. Bye, ma'am.